Hello, best and brightest. I'm just going to take a few minutes to show you how to use reference triangles to solve some basic trig questions. So let's say we got a question like the sine of 7 pi over 6. Sine of 7 pi over 6. Remember, sine on its own, by the way, it doesn't do anything. It always has to be done to an angle. We're always taking the sine of an angle. If we weren't, it would just be a sin, and we don't like to do those. So we're always going to be taking the sine of an angle. In this case, our angle is 7 pi over 6. Hopefully by this point you realize that that's in terms of radians. And the first step that I would suggest is that you convert that to degrees. If you're comfortable using radians, keep it in radians. But for a lot of you, especially since this is your first time seeing radians, it's probably going to be easier for you to convert that into degrees. Recognize that that pi is 180 degrees. So the sine of 7 pi over 6 is the same as the sine of 7 times 180 degrees over 6. 180 divided by 6 is 30. This is the same as the sine of 210 degrees. For our second step, we're going to draw our angle. Draw our angle. We're going to draw that 210 degree angle. So let's go ahead and do that. Remember, when we draw an angle, we're always going to draw it going from the x-axis. So I'll do it in red so we can see it. We're going to start along the x-axis. That's always our initial ray. And we're going to travel 210 degrees. So there's 180 and another 30. That's a 210 degree angle. Step 3. We're going to draw a reference triangle. A reference triangle is always the triangle that is made with the x-axis. So when we're drawing a reference triangle, we always draw it with the x-axis. We'll do that one in blue. We're going to draw the reference triangle with the x-axis. We're going to draw a right triangle. That's my reference triangle. And it should be obvious to everyone who's listening that this angle in here is 30 degrees. As soon as I see that 30, something inside me should say, oh, I've seen this before. This is a 30, 60, 90 triangle. And I know the ratios of those sides are 1 square root of 3 and 2. Remember that you learned in geometry that if you have a triangle with the angles of 30, 60, and 90, then the ratio of the sides are 1 is opposite the 30 degree angle, the square root of 3 is opposite the 60 degree angle, and 2 is opposite the 90 degree angle. So what am I going to do now? I'm taking the sine. I'm going to place myself inside at that origin. I'm going to look out. And I'm going to use SOHCAHTOA. I'm going to place myself right at the origin. I'm going to picture myself standing at the origin. And I'm going to look out. This problem asks for the sine. So what am I going to do? I'm going to take sine is the opposite over the hypotenuse. So we're going to place ourselves right here at that origin. We're going to look out. The opposite would be 1. The hypotenuse would be 2. Opposite of 1, hypotenuse is 2. So the sine of 210 degrees, I know the quantity is going to be a half. The last thing I need to do is I need to decide whether this is positive or negative. And there's a simple mnemonic device for me to remember that. For those of you who understood the unit circle, this is really obvious. It's going to be negative because sine goes with the y coordinate of this point down here. But if you don't understand the unit circle, we can remember that all students take calculus. All students take calculus. What does that mean? That means that up in this first quadrant, sine, cosine, and tangent are all positive. In the second quadrant, only sine is positive, the other two are negative. Down here, only tangent is positive. Both sine and cosine are negative. And in the fourth quadrant, only cosine is positive. Sine and tangent are both negative. So we are in the third quadrant. Only our tangent is going to be a positive value. So my answer is going to be -1/2. The SOHCAHTOA gave me that quantity of 1/2, and then I just have to decide whether it is positive or negative. I'm going to do one more problem very similar to that. If you feel comfortable with this and you want to zoom ahead to the end, you could do that and see if you got it correct. So the next problem I'm going to do is the cosine of 3 pi over 4. I'm not going to write out the steps for this problem, but if you want to reference the video earlier, you can. Our first step was to take this 3 pi over 4 and convert it into degrees. So 3 pi over 4. Remember that pi is 180 degrees. So 3 times 180 degrees divided by 4. That's 3 times 45. That's 135 degrees. 45 and 45 is 90, and another 45 is 135 degrees. So me asking you what is the cosine of 3 pi over 4 is the equivalent of me asking you what's the cosine of 135 degrees. My next step is to sketch the 135 degree angle. First we'll think about what quadrant this is going to be in. Well, since it's bigger than a 90 degree angle, I know it's not in the first quadrant, but it's smaller than 180. It turns out this is going to be a second quadrant angle. There's my 135 degree angle. It's 90 plus another 45. I'm going to draw my reference triangle. Remember, the reference triangle is always drawn with the x-axis. Hopefully it's obvious to everyone that 135 plus 45 degrees would get me to 180 degrees. So this is a 45, 45, 90 triangle. We can fill in now that this is a 1, 1, square root of 2. That's one of our 2 reference triangles that you should remember from your year in geometry. So if this, oh, that's a terrible right triangle, I apologize, but I'm going to leave it. That's 45 and that's 45. This is 1, 1, square root of 2. That's the ratio of the side lengths. For the cosine, we're going to place ourselves, we're going to place mini-me right in here, right at the origin. The cosine is the adjacent over the hypotenuse. So I'm going to look right next to myself. What's adjacent to me? Oh, it's 1. And what's the hypotenuse? The hypotenuse is always the side opposite the 90 degree angle, which is in this case the square root of 2. So the cosine of 135 degrees is equal to 1 divided by the square root of 2. My last step, I need to decide whether it's positive or negative. I know it's a second degree angle. All students take calculus, A, S, T, C. That's S up in that second quadrant. That means that only sine is positive, so my cosine is going to get a negative. I hope that's helpful. Have a good day.